Good morning, everyone. Well, guess it's not morning too much, but hopefully we got a good rest and we were able to go in and look at our notes. At this time, I'm going to go and go through our notes, make sure that we understand what's happening, that we got a chance to look and absorb the material for Unit 1 of our lessons. So I'm going to share my screen with you so that we can go through them. Please make sure you have your notes out, your blank notes preferably, so that you can start writing in them as you go through. Use this tape in case you miss class, or if you would like to just refresh yourself on what we went through in class. I will try to be as detailed as I can, but your annotated notes have all the detail in them. I will not write every single thing down because you can then go back and reflect on your annotated notes as well. Okay, so I want to go through and just make sure that we understand what's happening in the lesson and point out some things that you need to know for the test. All right, here we go. All right, so I'm going to open up our lesson notes. Here we're looking at our chapter 1. So before we get started, looking at the first page, starting on page 6 of your notes. So page 6 looks at the memory sheet, memorizing information on what we need to know. Make sure. All right. So at the bottom of the page for Unit 1, we're looking at our sets material here in this video. I sent out information in your email to help you set up flashcards. So this information for you would be very good on, on flashcards. If you do not like flashcards, that is fine. You can use it as a study guide. You can use it as a muscle memory to write your information over and over again. Whatever study tools you use this sheet that I sent you to help you, okay? Use it however you feel needed. First things first, we're just gonna go over our definition so we can make sure we know exactly what we're talking about. We're looking at, going to be able to tell what a well-defined set is, looking at elements, roster method, set builder notation, ellipse, and how to use that properly. Some of these things we've seen in our past before, so we're going to bring these back to our memory in this lesson. We're going to be looking at the empty set, which we know is the 0 with the slash. We've seen that in our algebra classes, right? Or using our parentheses with our squiggly brackets or set brackets with nothing in them. And then our other subsequent symbols that I'm going to go over right now. Okay, so let's do it. So here's our table. Again, I gave this to you in the flashcard setup sheet. Here it is, the beginning of your lesson. You need to know the words, the alternate wording, the corresponding symbols to go along with the wording, as well as what they mean or the definitions. Now feel free to rewrite these definitions in your own words, lay terms, and sometimes I'll do that to make sure we kind of know exactly what it's talking about. All right, here we are looking at the universal set. We're going to use a capital U for this. All right, usually it's kind of like a big slanted U. Here we're using just a very big uppercase U, means everything available in that particular problem or question. And they'll outline that for us so we'll know exactly what we're talking about. Union means the word or. Again, we've probably seen this before. It's represented by upper U. Again, noticing that it's different from our universal set U, right? The U for universal has our regular letter representation of the U. Here is just like a scoop. I call it like a scoop and dip, okay? So U representing union. Here they're saying A union B. In other words, union means to put it together, all right? But do not repeat the elements. So if something is repeated twice, so it's in both sets, you don't have to write it but one time. So we're just going to put things together. We merge things together. Whereas with the intersection, which means and, you notice that our symbol is an upside down U, right? It kind of looks like an A, doesn't it? Except for it's just missing that little crossbar to make the A. So you might want to use that as a representation to remind you that this is your A, right? Representing your and, which means intersection. What does that mean? It means what's in both sets. In lay terms, we could say what they share, right? What both sets share. Might be 3 sets, might be 4 sets, but what they all have in common or what they share. All right, the complement, which we use the word not. All right, and how we're going to see this, they're going to represent it in both ways. They're going to use an uppercase C or an apostrophe. Okay, this means what is in the universal set that is not in the given set. So if we say a complement, then I want you to tell me everything that is not in A. So after you look at what's in A, tell me what's not in A, okay? Cardinality, cardinal number or cardinality is read in of, and then they'll tell you the set in parentheses. So if you remember in algebra, we had f of x and m of x and all of those things. Here it's going to be read the same way. It's going to be in of A or in of whatever set they put in the parentheses. This simply wants you to tell how many elements are found in that set. And not just the number of elements, period, but specifically unique elements or items. So if something is repeated, you'll only count it one time. All right, so the number of unique items that's given in that set will be the cardinality. Note that the cardinality is always a number, okay? It is not a letter, it is not multiple numbers, it's usually just one number, okay? The empty set or null set, again, is represented by these two forms. Your set brackets, or lay terms, we call it the squiggly brackets, with nothing in them, or the 0 with the slash, all right? Set that contains does not contain anything. Then we have our elements symbol, which is like an E, all right, but it's like a swooping E. It is a member of or is an element of. So here we say that 5 is an element of A. What does that mean? It says the element listed on the left is in the listed list of elements in the set A. So they're telling me here that 5 is an element or belongs to the set A, right? And this may come as a true or false statement. We'll see that in some of the examples. Mainly, it's usually a true or false statement for you to answer. Then we have these two things, subset and proper subset. Now, if you notice that their symbols look very similar together, if you think about the math again or algebra, it kind of looks like a less than or equal to symbol, or less than symbol. So you have this U that's kind of turned on its side, right? But a subset has the equal to symbol on the bottom. That's going to be our remembering point right there. So subset says that A is a subset of B. What does that mean? That all of the elements in set A are in set B, right? But then look at the definition of proper subset. You notice it took that little dash away. So A is a proper subset of B, means that all the elements of set A are in set B. So you see the definition for subset and proper subset. The first part is exactly the same. But now here's the difference. For a proper subset, it says, but they are not equal. There are more elements in set B. So you see a subset has the potential of being equal to each other. Hence that little line at the bottom. So you remember less than or equal to. Okay, so a subset could be that A is a member of, or could be equal to the set that it's trying to be a member of. Where's a proper subset? All the elements, right, in set A are in set B, yes, but they can't be equal, okay? So proper subset can't be equal, right? So watch out. Put those little tidbits there, okay, so you can remind yourself. So now that we've gone through that, now let's go ahead and try to work some examples. Again, there's a lot more detailed information on your annotated notes. I'm going to talk through it here, and then you can go back and refresh yourself on the annotated part as needed. Here in our first example, problem number 1, it says, suppose we are given the universal set containing the elements 1 through 6. And they gave us some subsets, A, B, C, and D. And they contain some elements as well. You see that C has no elements in there, right? Okay. So it says, let's find the following. Here they're asking us to find A union B. Now, when you're dealing with these problems, it probably will be best if you write it out actually as if you were filling in a math problem. So A union B, write out what's in A, write out what's in B, keeping your symbol and your structure of whatever your problem is, keep the same structure so that you can then answer the question. As you start looking at the problem, some of you might be okay with just looking at what they have and then working from there. That's fine. But sometimes you'll start looking at the wrong thing. That's going to be an issue. Okay, watch that. We're going to start looking at things going to start running together. Watch that. Okay? So let's write it out. So we have A, write out what's in A. So here we have the set. A contains 1 and 2. They want us to union it with B. So in set B, we have 2, 3, and 4. Now, remember that union means we're going to put these two things together. But if anything is repeating, we don't have to write it again. So my answer is going to be a set containing 1, 2, looking at it, 3, and 4. And then close it up. And there's my answer. All right. A set containing 1, 2, 3, and 4. We saw that 2 appeared in each set, but I only wrote it once. All right, let's try B. Here they want A intersect B. So again, we know what the sets are. Again, I'll write them. We have 1 and 2. This also helps with our eye, training it. So we're going to intersect it with our B set, which is 2, 3, and 4. All right, so when we look at our sets, we're looking at the intersection of them. Remember, the intersection means what they share, or if they have anything in common between the two. So when we look, we have 2 here and a 2 there. That's the only thing. So right here, the number 2 and the number 2 is being shared. So in my little set brackets, I'm going to put the number 2. That is what's in both the sets. So the intersection of A and B is just the set containing the number 2. All right, how do we feel about it? It's pretty straightforward once we know the definitions. Again, you have to know what you're talking about so you can know what you're looking for. C, we're looking at B complement. So remember, complement means what's not in B. So now we know what's in B. Now, based on the universal set, what it tells us it has, what's missing from B. That's what we're looking for. So I'm just going to go ahead and put my little squiggly brackets because now I'm going to know that B contains 2, 3, and 4. What's not in there would be what? 1, 5, and 6. and close it up. So the complement of B would be 1, 5, and 6. Those are the elements that are not in our set B, right? All right, D says, find the cardinality of A. So here's A. A is 1 and 2. And they want us to find the cardinality of it. How many unique elements are in there? Well, clearly we see that there's only 2 of them. Now you don't need to put this in a set because it's not a set. This is just a number telling us how many elements are in the set. So we see that there's 2 elements in there. 2 is my number. All right. E, cardinality of C. Here's my C set. How many elements are in there? Nothing. So you can't put nothing as your answer. It has to be a number. What number represents nothing? 0. So everybody see what's happening. We're simply implementing our definitions based on what we went through and the information that they give us with our universal set and our subsets here. The sets A, B, C, and D that they have outlined for us. Now let's look at F. 5 is an element of B. Is this true or false? Looking at the set B, we see 2, 3, and 4, but I don't see a 5. So right there, I know that this is false. 5 is not an element of B. Right. But what about G? You see it has a slash through the E. Now it's saying that 5 is not an element of A. Okay, so here's our A. You know it's 1 and 2. Is 5 not an element of A? Nope, it's not. So that is true. 5 is not an element of A. Now, had they said 5 is an element of A, then it would be false again, right? Because 5 is not in this. But they're telling us, or asking us, if it is not an element, and it is not. Okay, so watch your wording and what they're asking you. All right, here's H. A complement. All right, so right here, pause the tape and see if you can try H, I, and J. They're talking about the complement of those sets. And then come back and we'll check our answers. All right, so let's see what we get. With H, they want a complement. So remember, we're looking at what's not in A. So we already know our friend A has 1 and 2 in it. So what's not in there, you should have 3, 4, 5, and 6. All right. All right, then we have the cardinality, the complement of C. All right, well, C has nothing in it. It's empty, right? So what would not be in C? Based on the universal set, it'd be everything, right? You agree with that? Yeah. So in our set, we would have 1, 2, 3, 4, 5, 6. And then you close it up. Or you could say the universal set. Because since we wrote all the elements in the universal set, then you could say just the universal set. Okay, not in brackets, not in set brackets or anything, because it is a set. The letter represents the set, so just the letter itself. Okay. J says the complement of the universal set. So the complement of the universal set. So our universal set has everything in it. So the complement of it would be the opposite, right? The empty set, or nothing is in there. So it'd be, how can we write it? Remember our squiggly brackets. It's not so squiggly. There we go. All right, representing the empty set, or the other symbol they gave us, 0 with the slash, right? Representing the empty set. So the complement of our universal set is always going to be the empty set, or some people say the null set, right? But the empty set is fine. All right. Okay, now let's look at K. Looking at our subset and proper subset. So it says A, is it a subset of the universal set? True or false? So remember, the slash underneath means subset. And we know that that means it could be equal, right? So our first question is, does all the elements of A, can be found in the universal set? Can they? Yes, they can, right? Right. So the answer, yep, true. All right. All the elements of A, 1 and 2, can be found in the universal set, so it is a subset of the universal set. But now let's look at L here. It says, is A proper subset of A? Now the little line underneath is gone, so that's why I know it's proper. And what does that mean? Now think about the definition now. Definition says we have to ask 2 questions now. First question, is all the elements of A, can it be found in A? Yes, okay. Now, do the sets equal each other? Here they do, but can they with a proper subset? They cannot equal each other, no. So our answer is false. It is not a proper subset. Why? Because they can't equal each other. And remember, how do we know? They took that little equal to, or that line from underneath, that means equal to. It can be, but it's not there. So it can't be equal to, okay? Let's look down here, M. It says A is a proper subset of the universal set. Again, we gotta ask ourselves the 2 questions. First question, do all the elements of A can be found in the universal set? Can they? We already said before that, yes, they can. Now, is A equal to the universal set? Are they equal to each other? Nope, they're not equal. So what does that mean? That means that it is a proper subset. So our answer is true. All right. As long as it's not equal to each other, it's a proper subset. All right. And then the last one, N. We have N of D. So they want the cardinality of D. But look at set D now. Watch it. They gave us multiple things going on in here. So set D has 1, 2, 3, 4, 5, 6, 7. 7 elements are located in there. But if you pay attention, you have some repeating numbers. And remember, the definition says that they have to be unique elements. Unique. So how many things? So first things first, we got to clean up our set. So we need to write all of our unique elements only one time, so we could just clearly see what's happening. So I see I have a 1. And then what I have? I have a 2. I have a 4. And I have a 6. So there's my set D, all cleaned up. No repeating numbers. All right? Now, the cardinality, I can clearly see it now. Remember, again, the cardinality is a number. How many unique elements do we have in there? 4. So remember, on the test, Pay attention to what they're asking you. Make sure you know the definitions and the meanings of your signs, the symbols, the words, all right? Because they can give it to you in any combination, right? Also note that on the online application uses DNE instead of our two notations for the empty set. So right there, when we use our empty set symbols for J, on the homework, they'll tell you in the directions when you read it that if it is the empty set, use DNE for does not exist. All right? So just follow the homework there. But normally, if I ask you and on the test, I give it to you in a multiple choice selection or something, I don't know. Problem number 12, who knows? Okay? Then you'll know that you need to select the right representation for the empty set. Right? So this is fine for the online world, but not for your quizzes, tests, or retests. Okay? So no credit will be given if you don't choose the right forms by ask you. All right? Let's move on to our next page. Here we are looking at sometimes we will want to work with the natural numbers. So we know our natural numbers are our starting or our counting numbers is what we call them. We start with 1, 2, 3, 4, and we go on forever, right? So here they are. You have this capital double N representing your natural numbers. And here they are listed out. And we have these 3 dots here. And these 3 dots here, that's our ellipse. This was listed in our breakdown in that first page that we went on that we were going to be talking about. Okay, our ellipses. You've seen it before. When you have those 3 dots, you notice we started off in a pattern, and then we put our 3 dots behind. That means that it goes on in that pattern forever and ever, and it doesn't stop, right? So ellipse helps us to write out our sets or our numbers or our patterns so that we don't have to write out everything all the way down to a million, gazillion, trillion, billion. And we know that exists somewhere in the world, right? Okay. So you're going to be asked to write or use your ellipse and know how to write at least 2 examples of it. Okay, so be prepared for that. We're going to do it in an example in a little bit. Number 2 says, given the following sets written in set builder notation, all right, so SBN represents set builder notation. So they give us A equals, here is read as the set of all x such that x is an element of the natural numbers. And now they're telling us something about x. X is less than or equal to 100. Then we have set B saying that the set of all x such that x is an element of the natural numbers and x is going to be greater than or equal to 100. So here they are using another representation, the set builder notation. You're going to be able to read this and be able to break it down and write it so that you'll know exactly what they're talking about. You're going to expand it out in a roster form. So roster form means to write it out to tell or show what numbers that you're talking about. So they're giving us this parameter or range of numbers where they're starting and where we're going. And we're just going to write it out in roster form. So what A we're talking about? A is where x is greater or less than or equal to 100. So in our squigglies, remember we're talking about sets, we always put in our set brackets. So here we are, our sets, right? And we're going to start with x is less than or equal to 100. So now if x is less than or equal to 100, and x is an element of our natural numbers, we know that our natural numbers start at 1, 2, 3, 4, and go on. But we know that x is going to be less than or equal to 100. That means that It's going to start at our first number, and it's going to go up to 100 and stop. Is everybody all right? Okay, so there's our range right there. So where x is less than or equal to 100, then we know that our set, written in roster form, should start at 1, 2, 3, 4. Okay? Then I'm going to use my ellipse right here. 1, 2, 3, right? There's my ellipse, telling me that it goes on forever and ever in that pattern, all the way up to 100. All right, so here's my set representing where x is less than or equal to 100. All right, now B says that x is going to be greater than or equal to 100. So if it's greater than or equal to 100, that means we're going to start at 100 and keep going on, right? So 100, 101, 102, on up to infinity and beyond, right? So when we write our set here, in our set brackets, we're going to start with 100, going to 101, then 102. You got to start your pattern so we'll know what pattern we're going in. Then you can put your ellipse in, right? But does this set stop? No. It started at 100. It's going on forever. We don't know where it's going to stop. So we're going to put our ellipse right here at the end and let it keep on going, and then close it up. So here we have two examples. Of how we can use our ellipse. All right, those are the proper way of using our ellipses. Now you can change these numbers and do it whatever you like. So your ellipse can be caught in between two things, right? Expanding in between. It could be coming from the front, going, or the back. Usually the front isn't necessarily for sure, because you don't have to, remember, you got to always establish a pattern. So you're thinking, oh yeah, I can start off and say dot, 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 10, 11, 12, 13, 14. No, you can't. Okay, don't do that. You're thinking, oh, I can just put it in the front. No, you can't. It has to be in the middle of something or taking something off to the end. Okay, those are really the only two proper ways to use that ellipse. So think about that, practice that. You will be asked to demonstrate that on the tests. Okay, here we are with part B. Find each of the following. Now we're going to use this information that we just wrote out to answer these questions, right? Okay, so it says, for each of the following, we're going to answer it. So what is the cardinality of A? So remember, here's our A. A starts at 1 and goes all the way to 100. So our cardinality for that, we see, is just 100, because there's 100 things that we can count in there, right? It goes from 1 to 100. So 100. All right, but what's the cardinality of B? What do you think? Can we count? We know where it starts, but we don't know where it ends. It keeps going on forever. So it's too many things for us to count. So what are you going to do? In the homework you'll follow, right? It'll tell you that if it's written a certain way or you can't count it, it'll tell you to use a certain thing. But we're going to write D and E because we don't know. It doesn't exist, okay? Since there's no, there's an infinite number of elements, right? It starts here and goes on forever. We don't know. So we're going to use does not exist, but usually you can also put infinity, right? It goes on to infinity and beyond. If you want to go back to the cartoon, we're saying, right? So D&E does not exist. Okay, what does this mean? To me, to count. Okay, goes on forever. All right, so does not exist. Okay. Then here we are using our symbols again. They want us to union these two sets together. So A union B. So A union B. Think about it now. Our A is 1 through 100. Our B is 100 on to wherever. All right. So if we're going to union these two things together, we would have starting at 1, 2, 3, 4. Okay. And then where is it going? It's going on forever. So now, can I just put my ellipse, right, and close it up? Wait a minute. Isn't that our natural numbers set right there? Okay. Or you could just write the double N representing our natural numbers. You could also spell out natural numbers as well. If you want, you can use this as the symbol. So it's our natural numbers, right? What if we do A intersect B? So remember, A goes from 1 to 100. B is from 100 to infinity, right? On and forever. Do they share any numbers? I see a number. Do you see it? Yeah. It's only one of them, isn't it? Here, 100 and 100. That's the number. So you have a set containing 100. Now it looked like it was going to be a whole lot more. But if you pay attention, they only overlap with that one number, right? Now they're asking us for the cardinality. So cardinality of A intersect B. The cardinality, I'm sorry, A union B. So the cardinality, remember, is just a number we can count. So we take and union those two things together. Now we've already unioned these sets together. We did it up here. We did A union B, and we got the natural numbers, right? So they now asking us how many unique numbers are in the natural numbers. Can we count those? Do we know? It's too many to count. It goes on to infinity. So what we're going to put does not exist. Okay, we don't know. All right. Then we want the cardinality of A intersect B. Again, we found A intersect B here. We found it to be 100, right? So what is the cardinality of this? What's the only thing in here? How many things? Just one thing. So the cardinality of A intersect B, just 1. Remember, not in set brackets, just the number 1. All right? So feel all right about it? Think about what we know about our terms. Still learning them, it's okay. All right, so now think about it. They're asking us some questions now. Are sets A and B well defined? Why or why not? So we see that A is from 1 to 100, and B is from 100 to on forever. Are they well defined? And well defined means, do we know for sure what's happening in it, what's going on? So if I look at the set and you look at the set, can we see the same thing? So when I look at A, I see 1 through 100. Do you see 1 through 100? Yes. When we look at set B, do you see 100 going on to infinity? Yeah, I see that. You see that. If Johnny, Tisha, Kim, Mary, if they looked at it, would they see it too? Yes, they should. Okay, so yes, this is a well-defined set because we're looking at the same information based on the knowledge that we know about our natural numbers, what we're talking about, the notation. We're all talking about the same elements. So when they ask us, is set A and B well-defined? Yes. We all see the same info, right? We're all talking about the same thing, same natural numbers, the same ones, right? With D, it says give a few examples of sets that are not well defined. So a not well defined set, think about it. If you looked at a set and I looked at a set, what would we have to write to where you would see something different and I would see something different? Here's an example. My favorite movies. Okay, my favorite movies. Is that well defined? No, because my list of favorite movies isn't necessarily your list of favorite movies, right? We have two different types of things that we like, right? You're not going to pick the same ones that I like, and I'm not going to pick the same ones you like. How about my favorite color? How about my favorite colors? How about that? You're not going to pick the same colors I would. Not going to do it. So that's not well defined because anybody who's looking at that is going to see a different set every time. Do you see what's happening? Okay, so these sets that we're picking, not well defined because I'm going to see something different than you are. And somebody else looking at it is going to see something different than you are. Okay, how about my favorite movie music groups? Not well defined. You like country. I like rap. She likes Western. I just like musicals. How about I like musicals and R&B. It's so many combinations that could be in this set. So this is not a well-defined set. So being able to look at a set and tell if it's well-defined by what's presented inside, that's important too. So once again, so you'll know what's happening, what you're talking about. Can everybody who's looking at that thing see the same thing? Can you see what's happening or what you're talking about? Okay? All right. So we've talked about our symbols, our words corresponding to the symbols, our natural numbers, and our ellipses and how to use them properly, and our set builder notation. Take this information and make sure you go through it again before you try and work the homework. Also making sure that you add to your flashcard sheet or using your muscle memory, whatever study aid you're using to help you solidify your definitions of these particular symbols and make sure that you're ready for this part of the test. All right, I'll see you in the next video. Okay, so make sure you're studying hard. All right, have a good one.